Please make sure that you have a piece of paper or your notebook available and a pen or a pencil so you can take notes as you review this video cast. Units of measure. In chemistry, we use what's called SI units, or the Standard International Units, which are also known as the metric system. When we measure mass, we measure it in grams or kilograms. Gram is symbolized by the letter G, kilogram by the symbol kg. Length, we measure in meters, or sometimes in kilometers, or sometimes centimeters or millimeters. Time we measure in seconds, or minutes, or hours, or days, depending on how long we need to measure. Temperature we measure on a scale called the Kelvin temperature scale, and that's symbolized by the letter K. In the metric system, we use prefixes. We use prefixes to indicate decimal fractions or multiples of various units. These prefixes tell us how much larger or how much smaller than a base unit a various measurement is. These indicate the decimal fractions or multiples of various units. Decimal fractions or multiples of various units. We'll start from the top. The largest prefix that you'll need to memorize is the prefix giga, which is symbolized by a capital G. It is 1 times 10 to the 9th, or a 1 with 9 zeros after it, larger than a base unit. A base unit would be something like a gram, or a meter, or a second. A gram, a meter, or a second would be considered what's called a base, or just basic unit. After that is mega. Mega is symbolized by a capital letter M, and it is 10 to the 6th, or 1 million times bigger, a 1 with 6 zeros after it, than a base unit. Next is a kilo, like for instance a kilogram or a kilometer, which is 1 times 10 to the 3rd, or a 1 with 3 zeros after it, larger. After this, you'd actually have a couple of other ones that work right in here after kilo. There's something called a hecto and a deca, which is 10 to the 2nd or 10 to the 1st larger. Perhaps you've heard of those before. And then you'd have your base unit. And your base unit, of course, would be the meter or the gram or the second. And we'll learn a few other derived units that you may be familiar with in a little bit. 1/10 the size of a base unit is symbolized by the prefix deci, which is symbolized by a small letter D, and it's 1 times 10 to the negative 1st, or 0.1 the size of a base unit. Centi, symbolized by the letter C, is 1/100th the size of a base unit, or 0.01. Milli, small letter M, is 1 times 10 to the negative 3rd, or 1,000th the size of a base unit. Micro is 1 times 10 to the negative 6th, or 1 millionth the size, and micro has a really unique symbol. Micro is actually the Greek letter mu, and it is written like this, kind of like a U, but with an extra little line on it. So there's like a U and you put a little line on it below. You could have a micrometer, you could have a microgram, you could have a microsecond, even, all with the Greek letter mu in front of it, meaning times 10 to the negative 6th. 1,000 times smaller than that is something called a nano. Perhaps you've heard of nanotechnology or nanometers. Those are things that are on the scale of 1 billionth the size of a meter, which would be a decimal point with 8 zeros and then a 1 for a nanometer. These prefixes, their symbols, and how much larger or how much smaller must be memorized by you. And we'll learn today, during this video cast, how to convert from one unit to another, to express one of these units of measure in kilometers as well as centimeters, or in megagrams and micrograms, all at the same time. We make many different types of measurements in chemistry, and one of the important ones is the measurement of temperature. We set up above that the standard unit of measurement for temperature was a scale called the Kelvin scale. The Kelvin scale is actually, or can be converted from the Celsius scale by saying that the Kelvin temperature is equal to degrees Celsius plus 273. There are three main temperature scales that you might be familiar with. These are the Kelvin temperature scale, the Celsius temperature scale, and the Fahrenheit scale, the one that you always hear about when we talk about weather. These are all related fairly regularly in that 0 degrees Celsius is actually equal to 273.15 Kelvin, and it's equal to 32 Fahrenheit. And so you can see that the freezing point of water is generally 0 degrees Celsius, 273 or 32, and the boiling point of water is 100 degrees Celsius, of course, and that's analogous to 212 Fahrenheit or 373 Kelvin. Notice that the increment of a degree in Kelvin is the same as an increment of a degree in Celsius. That's why you can convert between the two simply by adding 273 to the Celsius. Notice in the Kelvin scale, we don't use a degree symbol for Kelvin. We do use a degree symbol for Celsius and for Fahrenheit. If you want to know how to convert between Celsius and Fahrenheit, there's a good equation in your textbook right here that converts Fahrenheit to Celsius and also converts Celsius to Fahrenheit by using 9/5 and adding 32. Let's take a look at a couple of derived units as well. Derived units are ones that use more than one base unit. One of the more popular derived metric units is called volume. And of course, if you've got an object that you can measure the length times the width times the height of, you know what the volume of it is. Not all things are easy to measure the length and width and the height of, though. As it turns out, if you can measure these, and let's say, for example, you could measure them in centimeters, you would multiply the three units together, and then your units would be centimeters to the third power. And so actually, it's a unit of length cubed, and volume is a cubic unit. Now, what's cool is if it turns out to be a centimeter cube, there's a new name that's actually been given to that you might be familiar with. A cubic centimeter is actually renamed something called a milliliter. Now, if the length, width, and height were all decimeters, and therefore it would turn out to be decimeters cubed, this is renamed and known as the liter. And there's a great picture of this in your textbook on page 17. If I just zoom in on this a little bit, you can see that if you take a cube that's 1 centimeter by 1 centimeter by 1 centimeter, this would be known as a volume of 1 milliliter. And it's really cool that if you fill this with water at well, I guess technically it has to be about 4 degrees Celsius, but approximately room temperature, that water would actually have a mass of 1 gram, because the density of water at that temperature is 1 gram per milliliter, which we haven't learned about yet. And you can look up here, they actually have a cubic meter as well, and then they say one of those parts would be a cubic decimeter, which is actually what a liter is, a cubic decimeter. Our book uses these interchangeably, a cubic decimeter for a liter and a cubic centimeter for a milliliter. So get used to seeing both of those values, meaning liter and milliliter. A second derived unit that you'll need to be familiar with is one that I alluded to. That's called density. Density is mass divided by volume. taking an object's mass and dividing it by its volume. You might be familiar with this one already. One good way that I like to put this equation is to put it into a triangle. I call this the density triangle. Cover up the variable that you want to know, and what remains is the equation. Put a small multiply sign right here so you know these two would be multiplied together, and this line right here is like a division sign. So if you want to know density, cover that up with your finger. It's equal to mass divided by volume. If you want to know mass, cover up the m with your finger, and it's equal to density times volume. If you want to know the volume, cover up the v with your finger. It's equal to mass divided by density. We'll do a number of these types of problems as your homework in class, and I'll do some samples in this or another video cast as well. Since density is mass divided by or per unit volume, mass we generally measure in grams or kilograms, and volume we generally measure in milliliters, which remember is also a cubic centimeter, or we measure it in liters. And so we'll see density lots of times either in gram per cubic centimeter or gram per cubic decimeter, which remember is the same as a gram per liter, and this one of course is the same as a gram per milliliter. As I alluded to before, the density of pure water at approximately room temperature is 1 gram per milliliter, and that's why you can say that 1 milliliter of water is the same as 1 gram of water. Our first density sample problem says, calculate the volume of 65 grams of liquid methanol if its density is equal to 0.791. Remember, the density triangle says that density is equal to mass divided by volume, and it's in the shape of a triangle because then what you can do is just cover up the thing that you're looking for, in this case volume, and that's equal to mass divided by volume, or mass divided by density, or m over d. So, the way I want you to solve problems in this class is always very specific. You must show your work, and you must list the things that you're given, and then write out the equation and fill it in. So the first thing we're told is that the mass is equal to 65 grams. So go ahead and write this down in your notes, that m is equal to 65.0 grams. Get used to putting the decimal point and the 0 after it and writing in the units. Next, we're told that the density is equal to 0.791 gram per milliliter. Right now, get used to putting a 0 in front of your decimal point. Don't just put the decimal point in there, put a 0 in front of it as well. So then when someone's grading your advanced placement examination in a year or so, they don't think that you just have a fly speck on your paper. There's actually a 0 in front of there as well. So we know the mass and we know the density, and we want to find the volume. So write down the equation as it would be solved. Volume is equal to mass divided by density. Don't fill it in yet. Now take your numbers. Mass is 65.0 grams, and the density is 0.791 grams per milliliter. Make sure you put the 0 in front of the decimal point. The grams cancel with the grams, and I'm actually left with units of 1 over milliliters. Adding your units to each one of these measurements is critical. You must always include your units when you're doing calculations, and this will be for the entire course, so get used to it right now. Now if you take these two numbers on your calculator, 65 divided by 0.791, you end up with 82.2, and for right now you can just round to a decimal place or two, and we'll talk about how far you should round these answers actually in the next video cast. Since the units were 1 over milliliters, if you remember from math class, if you have a complex fraction like this, take the bottom fraction right here, take the reciprocal of it, and multiply it by the top one. So really I have 1 times milliliters over 1, and so our units for this will be milliliters, which makes sense because volume is measured in milliliters. Second sample problem for density says this: calculate the mass of a cube of gold whose density is 19.32 gram per cubic centimeter if the length of the cube is 2 centimeters. So once again, we're told this is a type of density problem because we're told the density. We know that density is equal to mass divided by volume. You can use the density triangle, and it wants us to find mass. So once you've written the triangle, cover up the M with your finger, and it's equal to density times volume. So write out what you know first. We know that the density is equal to 19.32, and the units on that are gram per cubic centimeter. Always write your units out. Always write your units out. And then the length of the cube is 2 centimeters. Now, you guys, if you've had geometry before, know that a cube is shaped something like this. And if you remember the definition of a cube, the length, the width, and the height of a cube are all the same as each other. So if I wanted to find the volume of this critter, I'd have to take the length times the width times the height. So we can write out and say that the volume would be equal to 2 centimeters times 2 centimeters times 2 centimeters, because it's length times width times height. So if we take 2 centimeters times 2 centimeters times 2 centimeters, we end up with 8, and carry your units along. Centimeters times centimeters times centimeters would give you centimeters cubed. Now they want us to find the mass of the cube. Since we know our density and our volume, cover up the M with your finger. Mass is equal to density times volume. So write out your equation. Mass is equal to density times volume. And then go ahead and fill in your numbers. The density is 19.32 grams per cubic centimeter. Always write out the equation first. Always write the number with your units on it. Do not neglect to write the units in. That's going to be multiplied by the volume, which we know is 8 cubic centimeters. Make sure to put your units in. And then you know that you can take any number and write it over 1, and some people forget this, that you could actually take this number and write it over 1. And since you can do that, you can see that there's a cubic centimeter on the top of this fraction, a cubic centimeter on the bottom of this fraction, and those two cancel or cross off for each other, and I'm left with the units of grams. Notice how I figure out my units first before I even do the multiplication or any of the things that I would have to do on my calculator for the numerical portion of the mathematics. Many times the units are just as important, if not more important, than the answer that you're going to get. When you multiply 19.32 times 8, you end up with 155. So these two sample problems are using the density triangle to solve for the variable mass, or in the previous case, the variable volume. You also could look in your textbook on page 20 to find an example of solving simply for the variable density.